Hi, Karen Banks here, and I'm going to go over an example of a sensitivity analysis very similar to what you're going to be doing in class. And if you have time, you'll be able to work on the sensitivity analysis for your project in class as well. But what I have set up here is an analysis that will provide some review of material we've covered throughout the quarter too. So on the information you're going to get in class, you'll get an Excel file very similar to this, where it'll have all the information on the tab that says base case, and then there will be a second tab that says sensitivity, and that's where I want you to build the sensitivity analysis. But this is just for review. We see we have the cash flow diagram. We have different types of cash flow set up here, what the depreciation is, taxable income, after-tax cash flow. We show future worth, present worth, and annual worth. We show internal rate of return on both the before-tax cash flow and the after-tax cash flow. We have the benefit cost ratio of both the before-tax cash flow and the after-tax cash flow. And we have the payback period, both simple and discounted, on the before-tax cash flow and after-tax cash flow. These are all things that should be very familiar to you, and you're going to get a project already set up very similar to this, remembering that in real life and on prior problems, you would be given the information for the problem, and you'd be setting this up to, you'd be given this information up here, and you'd be figuring out what the future worth, present worth, annual worth is. So this should all be review, but this will be provided to you so that you can use it as a starting point for your sensitivity analysis. We're going to use both goal seek, which you saw in a prior video, and then I call it a spider chart, but in one of the first videos you watched for this series, she called it a sensitivity graph. So what I'm going to have you do is talk about the base case information, which is what was on the prior table, prior tab, and you should be able to have a discussion that should you move forward with this project, why or why not, and discuss it in terms of all of the decision methods: the present worth, the annual worth, the future worth, the internal rate of return, the benefit cost ratio, and the payback period. And assume that a 3-year payback period is required for the project to move forward. And will all of those result in the same decision, why or why not? So you're answering these questions based on what the base case information is. Very similar to your project, you have the base information most likely for your project, and you should be answering the questions about your project in the same similar questions, okay? Then we're going to move on, and we want to complete a sensitivity analysis. So you know already from the information that you've looked at that what we want to know from a sensitivity analysis is at what value would the base case decision be reversed. So what do we know about the base case here? We know that our decision would be to move forward with the project because we have a positive present worth, as well as an internal rate of return that is higher than our MAR, which is the decision rule for that, as well as we have a benefit cost ratio greater than 1. I'm referring to all the after-tax factors here, but they're the same for before tax in this case as well. So our decision would be to move forward on this project. But we know that we're projecting out over 5 years, and so we want to perform a sensitivity analysis. How much would the initial investment have to change? Or, we're going to look at them one at a time, how much would the annual revenue have to change, or annual costs, etc., in order for our decision to be reversed, meaning to be not move forward with a project, but to say, no, we're not going to do the project. So I have the table set up here, the factors that we're going to look at, and this is what the most likely are. These are just copied. Anything in my files here, a blue means that it's a formula carried over from somewhere else so that you don't need to be touching that. And the black, you're going to get a template that the goal seek value is empty, and then these changes over here are empty as well. And then you're going to complete the analysis and fill these numbers in. So we know that when the initial investment is $50,000, that the investment is a go, that its net present value is positive 7.3. which we see here, $7.3 thousand, and so the decision would be to move forward. But what if our investment changed? How much would it have to change for us to say, no, we're not going to move forward on this project? So this is where we use goal seek, which we saw in the earlier video. We go to data, what if analysis, goal seek. And so we want to know when the present value, after-tax present value, becomes 0, that's when we're going to say, okay, well, maybe we could make this -1, but I just always choose 0. Then we're not going to do the project. And we want to know how much does the investment have to change in order for the net present value to drop to 0. So how much we want to set the net present value to 0 by changing the investment. So we hit go, and we see, oh, now we have investment of 0. Sorry, not investment. We have a net present value of 0, and our initial investment has to go up to $59,000. I'm just going to hit cancel, and everything's going to go back. But if I go back over here, I made note, okay, the initial investment would have to change to $59,000 in order for the decision to be reversed, to not do this project, because it wouldn't be worth it. And then I also like to look at it in relative terms. Not only absolute number would have to increase by $9,000, but that's an 18% increase. And so do I think that's a lot or a little? This, using the absolute number and the relative number, was talked about in the second video, where the gentleman went through the example using data tables and goal seek as well. So let's just do one more with goal seek. We want to say, okay, what if the let's see, data, what if, goal seek. So we want to set the net present value to 0. Now here we want to set it to 0 because that's the value that would change my decision. That's not always going to be the case. We might be comparing it to some other alternative, and so maybe it would be the net present value being equal to or less than whatever the other alternative is. But our alternative here is do nothing, so we're saying 0. By changing, this time let's say by changing the salvage value. So the present value, being set to 0 by changing the salvage value. And I hit OK. Oh, sorry about that. I had the wrong thing there. Okay. So I want it to by changing the salvage value. So hit OK. And now I can see my net present value is 0. And my salvage value would have to be negative $9,569. So I would have to pay to dispose of this piece of equipment rather than get anything from it. So negative $9,500. Again, I'm going to cancel. This goes back to what it was. Negative $9,500. I have this here, negative 9.6. That's a 200% change. So it's unlikely that I would go from getting something at salvage value to having to pay something. Now, it's not unreasonable that you would have to pay because sometimes there's cleanup and things like that related to disposal, but in this case, it would be a pretty big change. So this is answering this question right here. At what value would the base case be reversed for each factor in the table above? So if my initial investment went up to $59,000, which is a change of 18%, I would go from doing the project to not doing the project. If my salvage value went from $10,000 to me having to pay roughly $10,000, a change of 200%, then the decision would be reversed. I would not do this project after all. And so using goal seek, I went through and did that for each of the factors, and this is what it came out to be. So you can see that when there's a large change, that means it's not very sensitive. When there's a small change, I'm looking at percentages right now, then that means it's relatively sensitive to initial investment and annual revenues in this case. So that's one way I want you to look at it, looking at goal seek. And then I also want you to complete a sensitivity graph, build a sensitivity graph, which you see right here. And this is also what was shown in the first video that you watched for this module. So your table is going to have these values blank, and you're going to figure that out. So when I'm at my base case, my net present value is 7.3. But if I go and I say, okay, well, what if the investment increased by 10%, my net present value goes down to 3.2. Goes down to 3.2 and my initial investment increases. If I go back and I say what happens if my initial investment goes down by 10%, then my net present value goes up to 11.3. Goes up to 11.3. So I go through and do that. Each time I'm looking at a single factor at a time. I just chose 10%. I think the video might have had 50%, but you can choose whatever you want. And then I go through that for each of the factors, the same factors that I use the goal seek to see what is the exact change happen. I do that over here with a plus and minus 10%, and I can see then they get charted down here. The sensitivity graph is what it was called in the video. I also call it a spider chart. And so you can see that here is the base case, and then as the initial investment goes down, right? This is when the investment reduces by 10%, the net present value goes up, which makes sense because you have lower cost, versus when annual revenues drop by 10%, because that's what this net present value, when there's a 10% minus 10% change in the factor, then the net present worth of the project goes down because my income, my cash flow coming in drops, so therefore my net present value is going to drop as well. In the video it talked about we don't have anything, never do we go to 0 with 10%, which we see here that it is going to take more than a 10% change in order to reverse the decision. But what this chart does tell us, even though it doesn't tell us exactly where we would reverse our decision, unless we were to go out to 20 or 30%, it does tell us how sensitive, it's a good visual of how sensitive each factor is. So the steeper the slope is for any of these factors, the more sensitive it is. So for annual revenues, you can see it just takes a little bit of a change in either direction. A little small percent change makes a big change in what the net present worth is. Versus for salvage value, for example, we can see I can change salvage value a whole bunch and my net present value of the project hardly changes at all. So it's very insensitive to changes in the salvage value. And again, that's determined by the slope of the line. And it makes sense that as annual revenues go down, get less, that my net present value of the project also reduces. Just as it makes sense that as my initial investment drops, maybe I can negotiate better, maybe I find a cheaper or less expensive piece of equipment or way of doing it, that the net present value increases because I have less costs going into it. So that is the sensitivity graph right here. And then what I want you to do is, based on the sensitivity, does your original recommendation change? So in this case, our original recommendation was to move forward with the project because we had a positive present worth. Now, after looking at this, I would decide whether or not the sensitivity of the revenues, for example, or the initial investment, if that changes my mind because it's so sensitive that only a small change would reverse my decision, then maybe I would say don't go ahead with it. And then lastly, I want you to write a memo, no longer than one page, to the VP of Operations that you're completing this analysis for, stating your recommendation, both using information from the base case as well as a sensitivity analysis to have a more robust and complete analysis supporting data-driven recommendation supporting your analysis. And that is what you will do in class. You will be given, again, the base case very similar to here, and then you'll fill out the table at what value would it have to change to, and then the plus or minus 10% to build the sensitivity graph, and then communicate that via a memo to the VP of Ops. All right, and then if there's time in class, you'll be able to work on your project as well, since sensitivity analysis is required for that as well. I look forward to seeing you.